All right, so today we're going to talk about well, I have a supplement for you, and I'm going to give you the duplex receptacle stripping and termination nodes. This is basically what we are telling you during the labs, but now you can download and have this thing in a structured way, so you can use that in the future. All right. Right, so here we have, what do we have here? We have something that's called a duplex receptacle, and we already are dealing with this during our lab number 1. So some of us already have done it, and some of us are still waiting for this lab. So I'm going to give you some heads up on how things should be connected. Uh, this is just in addition to whatever we're giving you as a live demonstration during the labs. All right, so let's talk about stripping of the cable, stripping of the conductors. In the first picture, what I have, I'm just going to change my cursor. In the first picture is stripping. Insulation is stripped and conductor is intact. This is correct. See, the insulation is ripped. So it's partially cut almost to the end, but the grooves, the knife shape, kind of a, well, the groove that's knife shaped like a knife is not going to touch the wire. So the insulation is bitten almost there, but when you pull it sideways, the stripper, it is going to rip the insulation, the last part of it, without touching the wire. Remember when sometimes I'm telling you in the lab and in the lectures that every tool has its own personality? So once you use the specific type of tool, you're going to get attached to it and you're going to feel its action. You're going to know how that works, this particular tool. There could be the same tool, same model number, same brand, same whatever, and one might behave a little bit different than the other. So what I mean by this, in the wire stripper, you're going to have grooves that are labeled, for example, 14 solid. And on the other side, you're going to have a label that says 14 stranded. And those grooves are going to be slightly well beside each other. And you can, from the last lecture that we talked about the thicknesses and the gauges of the cable, solid versus stranded, you're going to notice that the stranded cable for the same ampacity is going to physically take a little bit more space than the solid conductor. So the stranded, because it has many strands of wires, and it has to have the same amount of copper to carry the same amount of current. So of course, if you put all those strands of conductors in one cable, in one conductor, to form a conductor, stranded conductor, it's going to take a little bit more space. If you have a solid core, which is right here, same amount of copper is compacted a little bit more, so that 14 gauge is going to be a little bit thinner in size, because everything is nicely compacted. So that's why you're going to have two grooves on the wire stripper, one that says 14, for example, 14 gauge solid, and there's going to be slightly tiny bit bigger one beside it that's going to say 14 stranded. Sometimes when I get the stripper, the wire stripper, uh, I noticed that the solid groove on the solid 14 gauge, it bites in a little bit too much, more than I want to. So in some of them, I'm going to say, yeah, even though it is a solid cable, solid conductor, this particular tool likes to, well, to be used with the 14 stranded, so the wires are not scuffed. All right, so the conductor is not scuffed. So what we have here is we're going damaged conductor, and this is wrong stripping here, because every time you damage conductor, look at that, the gauge is not, the weakest point is right here. Now this can be broken off if the scar is deep enough, but nevertheless we are not having the same gauge of conductor at this point. This is going to be the weakest point. Things can heat up and cause problems. So when you're stripping the conductors, make sure that things are nicely nice and clean after you strip the conductor. All right. We're going to talk about some positioning here, because we're talking about, with the duplex receptacle, we're talking about the screw terminals. There is also thing, and somebody asked me already, at the back here, because this is the front of the receptacle, that's where the footprint is, that's where you plug things in, that's where the plug is, with the shorter prong and the longer prong. And remember, the shorter prong is the hot one and the longer prong is the neutral. And how do you remember that? Is because the shorter prong, it uses the shorter word. Hot is shorter than neutral as far as spelling of the word. So that's how we can remember. The shorter prong is the hot one, and the longer prong is the neutral prong. Okay. All right. So so this is the side of it, this is the back of it, and this is the front. There are also connectors that you can see, those like if you turn it around towards the back, you're going to see a couple of like openings and holes that you can insert the conductor, and these are called the backstabbing holes, backstabbing connectors. So you strip the conductor in a straight line and you just push that in, and it has to be certain length. A lot of electricians, they try to stay away from those connectors, simply because you don't see that, you don't see the connection. You don't know how far this thing is being pushed, whether this thing was being pushed and ripped out, and maybe the connector is damaged inside. People are trying to stay, but still it is acceptable in the industry, but there's always that but. So that's what those things. But so we're going to concentrate on the screw terminals, right? And we're going to have the screw terminals without the compression plate. So the screw, there's the connector there, and the only thing that's on top of that is the screw. Sometimes you're going to have the compression plate, so it's going to be connector on the bottom, there's a compression plate, and there's a screw that's going to push that plate onto the other one. But this is not the type of connector that we're using. It's just a straight screw terminal. So as far as positioning here, in order to make a proper connection, you're going to have to strip the wire, something about here, and have the loop looped around the screw terminal, and you're going to tighten up the screw in order to make a proper connection. If you don't strip enough of the conductor, you're going to insert the insulation inside the connector. What happens is the insulation is thicker. Of course, the insulation is thicker here than the wire is. So if you pinch the insulation, you are making the connection with the insulation, not necessarily properly with the bare conductor that you should be making it with, which might result in partial connection. And when you have partial connection, you are going to have heat build up in there. You could have some sparking, you could have some heating up going on. And when things heat up, they will cause the conductor to oxidize, and it's going to be more resistive. And if it's going to be more resistive, the same current still will try to flow through that connection, but it's going to have a harder time. So things are going to heat up at this point, which are going to cause more oxidation, and which are going to cause more heat, and which are going to cause more oxidation and more heat, until if you plug in a appliance that is powerful enough, that draws enough current, you can actually start a fire in this type of connection. So do not pinch the insulation. Make sure that the screw terminal, when it attaches to the conductor, it makes contact with the bare copper only, which is supposed to do. Right? So pinched insulation is wrong. All right, what else do we have here? Positioning, what did I say here? Conductor out of bounds, that's what I called it. And then end of the loop is hidden. We've got two things that are wrong here. You see here, the position is correct here, except the insulation is pinched, but the position is correct. you gotta get this cable aligned properly with the whole socket that's there. So it goes from the back, goes around the screw nice and straight, and here's the end of that candy cane that we're making, except for the insulation can't be pinched. Over here, that whole conductor is kind of twisted out of position. That is wrong. Right? You might end up with good connection at first, but then things are going to be moving around, and that conductor can actually loosen up from the connector, and it can create a partial connection. Also, what I wrote here is conductor out of bounds, and then end of the loop is hidden. It is wrong. I don't see where this conductor ends. So it can go about here and stop, which would be bad because we do have a weak kind of a connection here. It can go up to here. I don't know. We want to see the end of that candy cane to make sure that, yes, we have a full connection made with the connector. And it has to go nice and straight into the socket right here. Not that way. Right? After it is been connected. Loop direction. Loop direction. It's sometimes some of us are having trouble with that. If you look at this is a correct loop direction. We're making the candy cane out of the bare copper, like a hook, sometimes called shepherd's hook or candy cane hook. We're making that half loop thing, right? Half open loop. The screw terminal, when you tighten, it goes this way, clockwise direction, just like that. So what we need to do, we need to make sure that when we insert that candy cane loop, the direction of the candy cane loop or the hook has to follow the same direction of the screw turning when it's tightening. That's extremely important. When we do it this way, once we're going towards the end stages of tightening, the screw here, the screw head, is going to start grabbing the conductor and it's going to tighten it around itself. So we're going to get a proper connection. That's correct. If we do it the other way, when the screw is tightening this way, and we're going to insert the copper wire, the bare copper wire, in the opposite direction of the screw tightening, as the screw tightens, it's going to stop grabbing the conductor and it's going to try to open it and push it out of the connection. So that will be bad. Make sure that the direction, so this is wrong. So what I say, loop opposes the tight turn or tightening turn. This is wrong. So make sure you know which way the screw tightens, which is clockwise, and have the loop following the same direction. See, we also see the end of the loop, so we know. Now we can see also here some copper exposed, but this is a picture of the whole loop, so I could show it to you before the screw is tightened. After the screw is tightened, we should not be able to see that. This should be all covered except for the end of the loop. Right? And I need to see the end of the loop because we need to see where the wire ends. It ends right here. The whole thing is wrapped around the screw terminal. If we don't see the end of the loop, as I said before, this wire could be just this long and could be just grabbed by the screw, and it could be wiggled out easily out of the connection as things are being moved around. Okay. All right. Exposure. As far as copper exposure, here's the front of the receptacle. Here's the back of the receptacle. This copper here, I want you to terminate in a way that once you strip the wire, that jacketing should not go past this housing here. So if you turn it around, so if you're looking at from the other side and you're looking at this, we should not be able to see the copper. If you turn the whole receptacle the other way. Now, if it's something like this, if you terminate things in this way here on the site, chances are that the inspector is going to approve your installation. But I want you to get into a habit of doing the job a little tiny bit extra properly here. Because it is extremely important that we develop the proper habits. What's happening on the construction site, in the field as you go and work. The electrician's job quite often what's involved there is working long hours. And when you work long hours, of course, at some point you are going to be fatigued, tired. And once you get tired, your quality level will have tendencies to drop. So if you develop the habits that involve a little bit extra quality, chances are that when you get tired and your quality of workmanship is going to slightly drop, it's going to drop hopefully down to normal. If you develop the habits of doing just enough as far as quality, once you get tired, there's a chance that you're going to get sloppy with your work and you're going to drop below the standards of the quality, below the quality standards. So also there is another wrong way of doing things as far as exposure of the bare copper, and it is this way here. Now this, once upon a time, I see this kind of let me just here. Once upon a time, I see a situation like this, where the stripped copper is way too long. Just think about it, guys and gals. When you strip the copper this much too far, and you manipulate the device, which would be the receptacle in this case, in the device box with other wires also stripped this far, chances are that this exposed copper wire is going to touch either a part of the device box or some other terminal or some other wires. Right? This here, and once upon a time, I do see something like that. It's way beyond acceptable. It's way beyond unacceptable. If you have it a little bit too long, you're going to say, okay, watch it, watch your exposure, watch your connections here, right? Over here, well, I don't want to say too much on the video, but it's a no-no. It's a big no-no, right? That's dangerous. Do not do that. Don't expose too much. But this here, that's okay, all right? Don't do that kind of stuff. So that's, I call it the exposure, the insulation strip much too far. And this is not just wrong, this is very wrong. Exposure conductor exposed, another type of exposure that we have that I notice when we are terminating the screw terminals. You see this loop here, how it goes. I wish that little information thing that is attached to my mouse would not be appearing all the time. I wish that PDF would solve that, but never mind. It's kind of annoying, so I apologize for that. So here's the candy cane loop. It goes around the screw terminal, and we can see the end of the loop. But we also see the copper exposed from underneath the screw head here. Please don't do that. Make sure that you pull things down so the whole loop is being covered. Well, whatever the area that is covering that the screw head covers, it should fully cover the copper. Simple reason, whatever is exposed is not making contact with the connector. So get into a habit of properly connecting. Don't get sloppy with your connections. When it comes to installation and connections, and that goes with the electrical systems, that goes also with the data systems, neatness of connecting things and wire management and the cleanness or the clarity of connections is extremely important. If you connect a connector or two, and that's the only thing you're connecting, if something goes wrong, you can quickly fix it. You still shouldn't do wrong job that is wrong, but it is easier to repair. But when you're dealing with 200 connections and you do 50 of them wrong, then you got a problem. Right? So get into a habit of connecting things properly. So this is wrong. I can see the copper sticking from underneath the screw head. Here is a correct termination. Is that the last picture that we have? Yes, that's the last picture. Look, I told you it was going to be shorter class. Here's a correct termination. The wire is unscuffed, so there are no scars in the bare copper. The insulation is not pinched by the screw head. So that means all the connection that's happening is between the bare copper wire and the screw head and the rest of the connector. The insulation is not stripped too far. It doesn't go beyond the housing. It's within, between the end of the coverage area of the screw head and the end of the housing. And we can see the proper loop direction because the screw tightens this way, which is clockwise. And the candy cane hook or the shepherd's hook or whatever the loop that we're calling it is following the same direction. And the copper is fully covered by the screw head. And I can see the end of the loop here. So I know that the length of the conductor or the wire is fully making contact and properly making contact with the screw terminal. Why do I not want to see the wire stripped beyond the housing there? Well, over here, if you have it, that's the borderline, all right? But if you have this thing stripped a little bit too far, if there's any wires that are hanging there or there's something drops in there, there's a chance that you can make a connection. If you slide it against the back, whatever metal object could be, if you slide it against the back of the receptacle, it is going to make a contact with the bare copper wire. Whereas if you do it correctly, if that happens, then it's going to make whatever metal object that could be there. Well, kitchen knife is one of the examples, which is bad example, but yeah. Then you are going to make contact with the insulation, which is okay. Our question here, white goes in silver screw, black goes in brass screw. Yes, that is correct. So the silver screws here are on the same side that the longer prong is here. So usually out of the box, you're going to have the silver screws, and that's where the white neutral wire goes. On the other side of that, you're going to have the shorter prong, which is the hot one, And the screw terminal, that screw is using, is going to be the brass collar. So that's where you connect the black wire or another hot or a switched hot wire, any wire that is not neutral. So it's considered hot. A switched hot is a hot that goes through a switch, and so on. So that would be the hot terminal, and it's a brass screw. But aside from that, we should also confirm, because what if somebody put the wrong screws in the manufacturer, which probably might not happen, but just take a look at the length of the prong. Here's the prong for the neutral, the other one is the prong for the hot, and that's how we do it. Also, since I have you here on this picture, you see here's one screw terminal and here's the other screw terminal. Internally, this screw terminal is connected to the prong of this outlet, and this screw is connected internally to the prong of that, and these two are connected with the tab. You can separate them, but just by removing the tab in order to create a split receptacle. Could we look for the grounding screw to confirm it was the neutral side? You're talking about this grounding screw or bonding screw. Well, yes, you can, but they are not really internally connected. So depending on, I wouldn't trust that, right? I don't think there is a rule that this should be on the same side when manufacturing, or they could be, right? But I would just look at the prongs, white prong or the long prong. Here are the screws, silver screws, that's fine. So that's where we're connecting, right? And quite often, after you've done so many of them, you'll be just doing that automatically. And I don't want to say the word with, I don't want to say without thinking, but in a habitual kind of a way. So here's the grounding screw, or quite often called a bonding screw. And we all know by now what the difference is between grounding and bonding, or the naming of the labeling of grounding and the labeling of bonding terminals. Okay. All right. So I'm going to make this thing available for you. I don't know, print it, frame it, hang it over your bed, and just look at it every night and every morning, right? Before you go to sleep. All right, so this is pretty much it for today's class. We keep going along with the labs. I am going to take one last look at our, well, not last look, but I'm going to take one more look at our class list, just to make sure that, because sometimes the list of names gets shuffled a little bit. I'm just going to confirm that all the last names, all the people are in the correct sections there. And if you still don't know which section you are, please, by all means, email it to me. Send me an email, and well, this or any other questions. Okay. All right, guys and gals, have a great weekend. Don't do anything that you wouldn't write home about, and nobody gets hurt. Have a wonderful, as I said, weekend, and I'll see you when I see you. Thank you very much.